If a square is inscribed in a semicircle, find the length, x. Area of a square, Pythagoras' theorem, and trigonometric identity are used to solve this question. Solution. Label points B, C, D, and G. Let R be the radius of the semicircle, where O is the center of the semicircle. Join O, G equals R. Also, let the side length of the blue square be Y. Hence, area of the square equals Y squared, which equals to 9. Take the square root of the equation. This implies that Y equals the square root of 9, which equals to 3. Using Pythagoras' theorem, the square of O, G equals the square of R, which equals the sum of 2 times the square of Y. Substitute the value of Y equals 3. This implies that the square of R equals 2 times the square of Y, which equals to 18. Take the square root of the equation. It follows that R equals the square root of 18, which equals to 3 times the square root of 2. Label point K, join line B, D. Let angle C be theta. From right triangle K, O, C. Length O, K divided by length O, C equals 3 divided by 3 times the square root of 2, which equals tan theta. We call it equation 1. Also, from triangle B, C, D. Length C, D divided by length B, C equals x divided by 2 multiplied by 3 times the square root of 2, which equals cos theta. We call it equation 2. By trigonometric identity, the sum of 1 and tan square theta equals secant square theta, which equals to 1 over cos square theta. Substitute equation 1 and 2. This implies that the sum of 1 and the square of 3 divided by 3 times the square root of 2 equals the reciprocal of the square of x divided by 2, multiplied by 3 times the square root of 2. Simplify further, so that the sum of 1½ will equal 72 divided by the square of x. Simplify. Cross-multiply and solve for the square of x. We have that x squared equals 72 times 2, all divided by 3, which equals 144 divided by 3. The result is equals to 48. Take the square root of the equation. Therefore, x equals the square root of 48. Which equals to 4 times the square root of 3. In units.